Today I'm going to be covering the Ford DPS6 transmission. The DPS6 transmission houses 2 clutches and 6 gears, and everything is electronically controlled. Breaking down what DPS6 stands for, D stands for dual dry clutch, P is for power shift, and S means that it's synchronized, and then the 6 equates to 6 gears. Some of the vehicles that you'll find this model of transmission in are the 2012 to 2014 EcoSport, the 2011 to 2015 Fiesta, and the 2012 to 2015 Ford Focus. The maintenance for this transmission is relatively simple. There's a check bolt on the side of the transmission that you can use to fill and check the fluid level of the transmission. It uses Ford's Motorcraft dual clutch transmission fluid and holds about 1.8 quarts. The price of this fluid is about $40 per quart, and Ford recommends changing the fluid every 150,000 miles. When checking fluid level, it should be right at the bottom of the threads for the fill port. And if you need to add fluid, you should add some until it flows back out, and then wait for the draining back out to slow down before closing it. Looking at the dual clutch setup on this transmission, it's very similar to a manual transmission, just that there's 2 clutches and basically 2 of everything, including 2 inputs to the transmission. And all of this is electronically controlled instead of being controlled hydraulically with a clutch pedal. There's 2 bearings that engage with the 2 different clutches. The larger diameter bearing is bearing A, and that engages with clutch A. And then the smaller diameter bearing in the center engages with clutch B, and these are what control the apply and release of the clutches. On the transmission side, you'll find the 2 input shafts, the smaller shaft being for input A and the larger shaft being for input B. And then you'll find the 2 engagement arms that engage with the bearings and control the engagement of the clutches. The clutch arms are actuated by the TCM through 2 electric motors, and these motors spin threaded rods that move rollers in and out underneath the clutch arms and push against a ramp to move the clutch arm in and out. Here's what that looks like in action. This transmission uses 2 motors, 1 for each clutch, and these motors are 3-phase AC motors, better known as brushless DC motors, and they have 3 Hall sensors in them to allow the TCM to know the position of the motor, which gives it precise control over the clutch engagement and disengagement. When it comes to the gear set, it's also split in half, with input shaft A being responsible for gears 1, 3, and 5. And this is highlighted in red in the diagram, while input shaft B is highlighted in blue and is responsible for 2, 4, 6, and reverse gear. The gray gear at the top is signifying the differential, while both the green gears on the left side are the outputs from each shaft, and these are both connected to the differential and how power flows from the input shaft through a gear set and then into the differential. Here I'm spinning input shaft A, and then I switch over to input shaft B. Here I just want to include a few photos of what the gear sets actually look like, and I have 2 different angles that show the gear sets with all of the shifting components removed, so that you can kind of get a good look at just the gears and the synchronizers and just how this transmission is actually geared together. Getting into the power flow for this transmission, here we have first gear, and we can see that power flows from input shaft A through the gear set and then into the differential. And for second gear, power flow switches from input shaft A to input shaft B, and then it again goes through the diff, and you'll see this is a reoccurring pattern that continues throughout all the gears, where it switches between A and B, which is how you get the advantages of dual clutch. And moving on to third gear, we can see that again it switches to input shaft A. Something else interesting to note is how it's sort of split in 2, with the odd number gears being to one side of the transmission and the even number gears being to the other side. Here we have fourth gear, and again it switches to the B input for the even number gears. And then we'll see here in a second that again it switches to the A input. And this just keeps going back and forth. So again, here's 5th gear. And then finally we'll get to 6, which again switches to the B input. And that will be our final drive. And here's 6th gear. Now with reverse gear, things are a little bit different because obviously you need to reverse the direction of power flow. So we have a torque coming in through input shaft B that then goes into one of the counter shafts, and then that counter shaft connects to the second counter shaft, and then that counter shaft delivers the torque into the differential, and that's how they're able to achieve a reverse gear with this transmission. Getting into the other half of the shifting for this transmission, there's 2 motors that are controlled by the TCM that are in charge of rotating 2 different shift drums, and one side will handle the even number gears, the other side will handle the odd number gears. But these shift drums move different linkages and arms that then will allow for the transmission to engage in the different gears. Here's a little bit of a better view of the shift drum and shift linkages. On the left we have shift drum B, which is in charge of 2, 4, and 6, and these are all going to be on the lower half of the transmission in this image. So you can see on the left side that you have the reverse and 4th gear shift linkage, and then on the right side you have the 2, 6 down below. And then on the right side we also have shift drum A. This shift drum is responsible for gears 1, 3, and 5. And in this image, it's the 2 upper linkages on the left and right side that are responsible for those odd number gears. Here's another look at the TCM and how the 2 motors are built just directly into the TCM. Getting into a bit of the electrical with this transmission, there's not that many sensors. There's 2 input sensors, one for each input shaft to watch the speed, and then there's 1 output speed sensor looking at the differential. And then finally we have the transmission range sensor. When it comes to the various sensors that the TCM is looking at, you have the 4 that are inside the transmission, and then it's also monitoring all 4 motors, the 2 for the shifting and then the 2 for the clutches. And then you also have the shift select switch that the TCM all takes as inputs, and then it outputs to the 4 motors, and that's all it's really in control of. And then it also has communication over a high-speed CAN line to the BCM, TCM, ABS, and so on and so forth. There's a few things to take note of when rebuilding this transmission. One of them being that you need to remove the speed sensors before taking the case off. If you do not, they will get held up, and if you try and forcefully separate the case halves, these sensors will get damaged. The next thing to note is there are 6 10mm bolts on the one half of the case, and these hold retainers that hold the bearings inside the case. So you need to make sure that these are removed to be able to remove the case half. When working with the clutch, one thing to note is that these markings need to be lined up correctly for the splines for the clutch A. When dealing with the splines for clutch B, which is under the splines for clutch A, you will need a special tool to compress the clutch down into the housing to be able to remove the C-clip because it is under spring tension currently, so it's not easy to remove it or reinstall it without a special tool to compress the clutch. And finally, one of the biggest issues this transmission has is that the input shaft seals leak, allowing oil to get onto the clutches, causing contamination in the clutches, which leads to poor shift quality and clutch slipping, which leads to just a bad drivability experience. Thanks for watching.